Right, in this video we're going to look at the mean and variance of a continuous uniform distribution, and we're going to prove some special formulae that apply for this case. Reminder of what the PDF for a continuous uniform distribution, it looks something like this. Okay, that's our PDF, and the graph of that looks rectangular, sometimes called a rectangular distribution because of that, because the PDF is a rectangular in the shape of a rectangle like that. Okay, now the mean, it's pretty clear what the mean is. It's going to be the average. It's going to go halfway in between here by symmetry. That's b plus a over 2. The variance is less clear why this is the case. I'm going to prove this later on. Is equal to b minus a squared over 12. It's in the formula book. We're going to prove it. Let's use it first in the case we did in the last video. Remember the one where we said 70. The number is 70. Let's write the PDF for it. And that means that it's 1/10 for any value between 65. This was the one that was rounded to the nearest 10 or to one significant figure, so it was a number that has to lie between 65 and 70, and it's evenly distributed throughout. Right, well, using these formula here, using the standard formulae, pretty clear that the mean is 70 and the variance is going to be equal to 75 minus 65, which is 10. The difference between those two, 10 squared over 12, which will be equal to 50 over 100 over 12, which is 50 over 6. Okay, so that's the variance. So that's how to use them. It's pretty clear. It only works for this type of distribution. And someone asked me in the lesson recently that why don't we use the normal ones that we were using before? Ex is equal to integral of x fx dx 75 to 65, and the variance, when we work that out, that gets to the number 70. Why don't we do that? Well, the reason is because it's slower. This is just more using these special cases, just makes it quicker to do, and that's it. Okay, it's quicker to do. If you have to work out the variance, it's just a bit more fiddly. You'd get it right, but you'd be penalising yourself in the time if you were to use the variance one in particular, which is equal to sigma fx x squared dx minus mu squared. Of course you're going to get, you can try it if you want, you're going to get this answer. It just wouldn't come as quickly. And being as these formula are in the formula book anyway, we might as well know they are and use them when we need to. Now, one important thing that could come up in the actual S2 exam for Edexcel is to actually prove this result. Okay, these results. Well, the mean is kind of obvious. It's by symmetry. Let's go back to blue. The mean is it's obvious here really by symmetry that mu, which is equal to ex, is equal to b plus a over 2 by symmetry. I think you've pretty well nailed it by using those key words, by symmetry. Okay, so, because evenly distributed, same both sides. The variance, well, let's go to the variance formula that we normally use in these for the general PDF. That will be x squared. Now it's times by the function, let's write it this way, 1 over b minus a, because that's x squared dx. Now the limits, because the function only has values between b and a, are b and a, take away mu squared, and mu is b plus a. Okay, so there we have, so we're going to work with that and hopefully we'll get to here. Okay, right, well, let's just do the integration, should be fine. There's a little bit of algebra to come there. Right, so the 1 over b minus a is just a constant, so that shouldn't trouble us, just leave it as a constant. X cubed over 3 between b and a is the integral of that. Let's just not do a great deal with the square for the moment, but I will call it b plus a squared over 4. The square in the bottom. Right, okay. Then I can put my limits in here. If I put my limits in, I will see that I have 1 over b minus a times b cubed over 3 minus 1 over b minus a times a cubed over 3 minus b plus a squared over 4. Okay, this would be, these two terms here would be easier factorised really, because we've got a common factor here and here, and we've also got a common factor of 3 as well. So I'm going to rewrite that. I could have done this in the first line, to be fair. Could and perhaps should have done it like this. And then I would have, I would be left with b cubed minus a cubed on the top. I've still got minus b plus a squared over 4. Now let's make a little bit more space on the right hand side here. Right, so that's better. Now I'm going to work with this cubic thing before I do anything else, because otherwise it might get a bit ugly if I do a bit of expanding and try and put over a common denominator now. Let me tell you that it's not going to be pretty. If I start putting the 3b minus a and the 4 of a common denominator now and start multiplying them out, it'll be okay, but it's just not going to be the nicest way of going about it, I don't think. So I'm going to, let's write this down here. There's some well-known factorizations, I'll write them in terms of x and y, that perhaps it might be worth you knowing. X cubed minus y cubed is equal to x minus y. For those who've well practiced in these things will know these, and it is worth knowing. They don't tend to come up these days as much as they used to. Multiply that out, and you'll see they're the same. Okay, and the equivalent to that, not used here, is x cubed plus y cubed is equal to x plus y, x squared minus xy plus y squared. Okay, and you'll find that that all cancels out. You'll find that that works. If you don't believe me, just check. They're worth knowing those. And that's, I think, the easiest way of proving this formula. I think it's the best way. So let's do it. Okay. So let's do it. I'm going to factorise this top bit now. So that top bit is equal to b minus a, using the first of these, b minus a, b squared plus ab plus a squared, all over 3b minus a. So now perhaps you'll see why I preferred to do the factorisation now of that rather than put over a common denominator. The way we go about our algebra can make a big difference, so as to the kind of efficiency of it. So b over a, b minus a. Okay, so that's that. I'm now going to put over a common denominator of 12. That's kind of promising because we want 12 to come in our final answer here. So go back to blue. So that equals to 4 times by b squared plus ab plus a squared over 12 minus 3 over 12. I'm going to now multiply these out. So that's b squared plus 2ab plus a squared. Right, now I can put over a common denominator. It's over a common denominator now. I can see I've got 4b squared and 3b squared and the difference between those two. So I'm going to end up with a b squared there. I can see I've got a 4ab and a minus 6ab when I multiply those out. So that's minus 2ab. And I can see I've got a squared, a 4a squared, so let's say, that times that, and a 3a squared, that times that. So that gives me plus a squared all over 12. And the top factorises. That gives me b minus a squared over 12, which is what we were expected to show. So we've done it. Nice feeling, a little bit of algebra to do. Okay, apologies if you can hear a barking dog in the background. Someone's knocked on the door. Yeah, that's quite nice, isn't it? The book, the newer version of the textbook, by the way, does it slightly differently. But this is actually more like the old blue textbook does it, and I do prefer it. I think the new one has some stack fractions in I don't like, and also it kind of, I think it's trying to avoid this factorisation thing, which I think is not a bad thing to actually know anyway. So that's it.